Hi guys, so thank you and welcome to our second part of the topic of Introduction to Organic Nomenclature. As we said, this is just basically discussing some of the concepts that we have already learned or reminding ourselves of some basic concepts which we shall need as we go along in naming organic compounds. And these ones are going to give us a basis for trying to understand their various chemical and physical properties so that we are able to tackle some topics that we find as we go by, like reactions and then mechanisms of organic molecules. So for that case, thank you and welcome. So as we said that organic nomenclature as a topic or a subtopic entails the naming of organic compounds, and there is specific rules which are generally accepted. Which are generally accepted as the ways in which organic compounds need to be named. These rules entails assigning of specific names and we shall look at the Iupac, which is the International Union of Pure and Applied Chemistry. Now, this union comes up with specific rules for naming these organic compounds for the sake of consistency, in communication. Among a community of maybe scientists who basically involved in research and the use of these particular chemicals, or some industries that entail or involve themselves in imports and exports. So it's of an essence that maybe those who are dealing in commerce of organic compounds understand specifically what the names entail so that they are able to get the information that is consistent between the exporters and importers. So in that case, also in the scientific community, for the sake of consistency, we have to come up with specific rules. So in organic nomenclature, there's a format that is usually followed. This is a procedure whereby you find that in naming a compound, there's a specific prefix that need to be used. And we have already seen about the concept of functional groups. The functional groups that we have listed, of course, we said they dictate the physical and chemical properties. And also we say that alkanes as a class of organic compounds form the basis for naming of organic compounds. So for that case, we shall have a parent name. We shall look at what a parent means in this essence or in this context, and then we have a suffix. So for just a normal slight or just a rough definition, a prefix is the part of a word that appears immediately as the word starts, and then a parent is the middle part of a word, and then a suffix is the ending of a word in that case. So for organic compounds, there are those molecules that attach themselves to the main or the functional group. We call them by the name substituents. These are molecules that attach to the functional group or the parent. Of course, we said about the ability of carbon to form long chains, chiral compounds, and complex molecules. So for that case, this parent name is given for the longest chain. For cyclic compounds, we shall look at the functional groups, of course, which dictates which kind of compound is being named. And the suffix, this is a family of organic compounds. So in this case, it's essential for us to try and figure out what is a substituent And how do we determine the longest chain and what category of a family that particular organic compound falls under? Now for that case, apparent in that case, actually this is the basis upon which all the organic compounds are formed. And this one basically refers to the alkane names of this particular compound. We said that alkanes are molecules that are formed up of carbons and hydrogens. So alkanes form the parent for naming of organic compounds, and they have a general formula of carbon that is attached to hydrogen. And if there are n number of carbons that are attached to that particular hydrogen, then we shall have 2n plus 2 atoms attached to that particular number of carbons. So if we try to look at this just in a slide details, we have the general formula for alkanes, 2n plus 2. So this n represents numbers ranging from 1, 2, 3, 4, 5. So for the alkane series that form the basis for naming of organic compounds, we have the first, second, third, fourth, and fifth compounds that form the parent part of an organic compound's name, as we have already said. Now for that case, we shall look at the parent alkane names that fall under this category and try to see as we go along how different alkanes members are being used to name different organic molecules in that case, or they form a basis for that. So the first member of an alkane parent is known as methane, that consists of a single. So we shall have to look whether they are inconsistent with the formula that we have listed, that alkanes consist of a carbon bonded to hydrogen with those particular number of hydrogen. Of course, we have said that n can be 1, 2, 3, so integers, 4, 5, etc. So for that case, the first member is known as methane, and its formula will be C1H4. So if we do a substitution for 1, not necessary for us to indicate it there, but this is a single carbon atom, then for 1 we shall have 2 times 1, 2 plus 2, 4. So that's the first member of the alkane series, or the parent name for the first member. So the second one is ethane, that is C2 H2 times 2, 4 plus 2, 6. So the third member is known as propane, that is C3 H3 times 2, 6 plus 2, 8. The fourth member of the alkane series is butane. It consists of 4 carbons and H 4 times 2, 8 plus 2, 10. The fifth member, we shall look up to a range of around 10 members to just form a basis for us in naming of those organic compounds. It's known as pentane. Pentane, C5 H5 times 2, 10 plus 2, 12. So for this case, we shall just have to do away with this, or we just move it somewhere here so that it can be used as a reminder for us. So the sixth member is known as hexane, and it consists of C6 H6 times 2, 12 plus 2, 14. And then the seventh member is known as heptane. This consists of C7 H7 times 2, 14 plus 2, 16. And the next is number 8, octane. We talked about the octet rule, so for that term the prefix oct means 8, C8 H8 times 2, 16 plus 2, 18. And then we have member number 9 of the alkane series, known as nonene, C9, 9 times 2, 18 plus 220. And then the last member, number 10, is known as decane. Decane, C10 times 220 plus 2, H22. So this one forms a range of, from the format that we are given a prefix, parent name, suffix for organic naming. Parent names are made up of the alkane series, which we have listed, of course, from the member number 1 to 10. And this is the general formula for allocating of the carbon and the hydrogen atoms, the alkane structure. So for that case, whenever we mention this particular name, now from the third or the fourth member, you can see that the prefixes entail the use of specific names that are attached to the number of carbons in those particular parent group. So in that case, these are the Greek or Latin names that are being used to denote the number of carbon atoms in those specific molecules. So in that case, we shall have that one in mind. Now from here, you find that apart from the alkane series forming the basis for the parent name for organic compounds, we shall have also, we talked about substituents as molecules that attach themselves to the parent group. But when a compound consists of a particular functional group, also we shall have a specific name. We talked about functional groups like alkenes, alkanes, ketones, aldehydes, amides. So when a substituent, so we shall have a substituent name. That was the prefix. Remember we talked about the prefix, the parent name, and then the suffix. This is a format for naming of organic compounds. For the parent name, we have said that this one comes from the alkane series that we have listed on the board. And then for the prefix, which is a substituent name, we shall look at a few substituent names that we shall use, of course, in naming of the organic compounds. For a substance that consists of a carbon single bond, the name that we shall use for this is alkyl. That is a substituent name for a compound that consists of a carbon bond, single bond. Or not necessarily a single bond. We shall look at some of the examples. But for that case, we shall have another compound that consists of this. For a compound that consists of that functional group that consists of a carbonyl, and this one, this is an acyl group. Acyl, that substituent is known as an acyl group, and it ends with oil. So when we're going to name a compound that consists of an acyl group, that is the suffix that is going to contain, of course, for some exceptions like acetyl maybe, which we shall have a different name for that. So we shall discuss about that. But our main agenda here to look at the substituent and the common names or the specific names allocated to them. Now for a compound that consists of a functional group of this, or a substituent of that nature, this is an alkoxide. That's an alkoxide group for that substituent. And then for a functional group, for a substituent that consists of this particular substituent, this will be known as a formyl. It's a formyl. And then for a substituent that consists of a carbonyl attached to the R groups, this will be known as a keton. Remember the functional group that we talked about, ketones. So for that case, a substituent with this particular nature is known as a keton. And then for a functional for a substituent that is attached to this particular molecule, or a substituent with that particular molecule will be known as hydroxy. And then for a substituent, this is known as a nitro, NO2, that's a nitro. And for a substituent with this particular form, it's known as amino. And then lastly, we use this one to denote halogens. These are group 7 elements that include chlorine, bromine, iodine, etc. So for that case, this one we shall have their name for specific compounds. So if it's bromine, then we shall have bromo. For chlorine, we shall have chloro. For iodine, we shall have iodo, etc. So for a substituent that contain a halogen like bromine, chlorine, and iodine, we shall use these specific names. So that is in as far as the format for naming of the organic compounds and the substituents are concerned. So we shall look at another aspect, which of course is configuration. So these particular organic compounds will appear in different forms, maybe with an altered structure. We talked about isomers. So there are some of the compounds which are going to display some different properties apart from the isomers, or there are specific names that we shall use for compounds like isomers, which display different structural formula, but the molecular formula is the same. Now for alkenes, there is a configuration. A configuration is basically a rearrangement. There are two specific configurations that appear for alkenes. The first one we call it a trans, and the next one we call it a cis. Now these particular two characteristics for alkenes appear because of the rigidity of their double bond. Rigidity of the double bonds of alkenes, which means there is a way in which these particular molecules conform or try to change as they are formed, but there is an aspect of finding that the alkenes have the ability of forming a rigid double bond, and of course for alkenes they also form a very strong triple bond. So for that case, it will be very difficult for a rearrangement to occur. So in that aspect, you find that there are only two specific arrangements that form in as far as alkenes are concerned. So for that case, we shall have a demonstration for this particular characteristic for alkenes. So we have talked about the trans and cis rearrangements. So there are also other specific names that are used for this, but we shall use that demonstration to show. So we have a carbon-carbon double bond in the first instance and a second one, and then they are attached to other molecules like that. So you would find that for this particular alkane, if we have, okay, use a brighter color. If we have a molecule attached to the first alkane, let's say denote it a molecule by the letter Y, and a similar molecule as the first one is attached to that, and there's another molecule, let me use this. Now in this instance, this one does not indicate, just a general general, just for demonstration. Does not indicate an halogen, or just for the sake of visualizing this one, I've just used this specific letter. So you can see that this one is the same as this, and this one is the same as this. So when molecules appear across as such, that is when we shall have to be using the term trans to indicate that in that structure of that particular molecules, those atoms have a rearrangement of that particular order. So there's a second case, we just moved it down. There's a second case of this particular alkanes whereby you find that instead of these molecules aligning themselves as in the first case, we shall have molecules appearing this way. So the Y appearing with the Y, X appearing with the X. So which means the molecules are appearing on the same side. So you can see that particular rearrangement. We shall talk about this one in the details about the rearrangement or configuration of these particular molecules. But what we were interested in is these particular terms which we shall come across. The first one is trans and cis, which implies that these molecules have this particular specific configuration in their structure. So have that one in mind. The first one means that the molecules are across, trans, and then the second one means that they are on the same side. Now there are specific terms as well that are being used for this. So in our case, we shall come across an initial Z and another one A. Some molecules might have the initial E or Z that is attached to the names. So that one's in an essence, those are the German names that are being used to denote the molecules. Of course, they stem from the original, someone who came up with the concept. So this in German means zusammen, which means together. While the second one, entgegen, that refers to across. So if you look at the structure of those particular compounds, you find that for a cis, the second one has a Z, just donating, and then for together, Z. Okay, for a Z, you'll find that the molecules appear. Okay, I'll just confuse this. Z for across. Oh, this is Z for together. Sorry for that. This is together. Some new terms have some kind of a confusion. So this one means across. Okay, let's note that correction. So for that case, for molecules that will have a starting letter A, zusammen, that one is a bit of confusion here. So this is Z, E. These are the initials for the words for our remembrance. So for zusammen, that one means across. Or make confusing. Sorry for that. You have to make a correction at the start so that we do not have the confusion. So we start from this point. For the trans, the molecules are across, and then for the cis, the molecules appear together. Now for the for the terms that we have mentioned, Z implies zusammen, which means the molecules are together, and A implies entgegen. Don't know whether that's the correct pronunciation, but this one implies across. So for that case, this letter refers to the trans, and this one refers to the cis in simpler terms. Okay, we can go ahead. There's also a different set of rules that are used for configuration assignments, different ones. These are just the two that we have mentioned for trans and cis, and then for E and Z. But there are different, there's a set of rules that is used for configurations of different molecules. This is the Karl-Ingol prelog. The Karl-Ingol prelog, we shall look at it later, of course, because it has got also specific rules for this particular. So since we shall come across a few of the molecules that will require that one, we shall just reserve it for the topic of conformation and the configurations of molecules. I've talked of the term configuration, the one that we have mentioned. These are just a fixed stereochemical property of compounds. So a fixed stereochemical property of compounds. So these terms are just not different. This statement means in an essence that rearrangement of compounds, which is appears in a specific format, or which is just fixed. The ones that we have said for alkanes, they appear in two, that is for cis and trans. So this one is going to assist us in naming of organic compounds. We can just give a few, maybe just a single example for that, for us to move fast. So we have a compound of an alkene compound. Put the bonds like that. And then we have these molecules attached, CH3, HH, and then CH3, 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 HH. So now that we have talked about substituents, there is a way in which we are going to refer to these particular molecules. But for us to just jump ahead, of course we have not stated the format for naming that, but we shall look at how the word trans and cis have been used. So the first compound is known as trans. The first compound is known as trans hyphen built hyphen 2 in, and then the second is known as cis built hyphen 2 in. So what are we trying to demonstrate here? Whenever we use the term trans, we are referring that the molecules of this particular alkanes appear across one another. So in as much as they may have the same molecular formula, because we have two methyl groups and two hydrogen groups in that particular structure, and the alkane functional group is just the same. So in as much as we have those, these terms are going to assist us differentiate between the structure appearance of that one and this one in so far as configuration is concerned. So that is why we have to use the term cis and trans. So I'll try to look at the concept of configuration. So as we go ahead naming organic compounds, if you come across this particular term, remember that one deals with the concept of rearrangement. So of course we said that those are the major two rearrangements that appear because of the rigidity of organic compounds. So later we talked about isomers. Of course this one is an isomer of that, as we mentioned, because they have the same molecular formula but different structure formulas. And then so alkanes have the ability to form isomers, and there are different isomers. Of course, this one deals with there are different isomers that result from alkanes, of course, which is going to affect the naming. So as we looked at the cis and the trans, or Z and E concept, there's an aspect of isomerism that we talked about. We're just going to expand it a little bit further, just shortly, so that we can be able to understand some of the concepts. So for an isomer which is consists of the same molecular formula but different structural formulas, they are known as constitutional isomers. Now for constitutional isomers, they have the same molecular formula, but a different structural formula. So for constitutional isomers, they have the same molecular formula but different structural formulas. We have a second category of isomers that are known as positional isomers. Now for positional isomers, they have the same number of carbon and hydrogen atoms, but the position of the double bond is different. So this one specifically deals with the position of the double bond, which means when the position of the double bond differs, that one forms what we call positional isomers. Now lastly, we shall look at another class. So we have talked about constitutional isomers, whereby the molecular formula is the same but different structural formulas. I mean, different structural formula. And the second category of isomers is positional isomers, whereby the position of the carbon-carbon bond is different. Lastly, we shall look at the skeleton of isomers. The last category of, apart from constitutional and positional isomers, what number 3, what we call skeletal isomers. Now for skeletal isomers, these are basically cis trans isomers. Skeletal isomers are the cis and trans isomers. Of course, that ones we have already discussed, whereby each carbon atom in the double bond contain the same groups, but their positions are different. So fast forward, of course, we have different conditions for isomerism to occur. You find that that each of the carbon in the double bond consists of different groups attached to each, like the one that the metal and hydrogen that we saw. That is why we were indicating about the X and Y, or the Y and X respectively. So in that case, each of the carbons and isomer are attached to two different groups. Whereby the cis we have indicated for the cis, whereby they appear, for the cis they appear on the same side. For instance, it's a cis. For the trans, they appear on the opposite sides. So next we shall look at a different concept. We mentioned about the Iupac naming system, and we said that it's a set of rules that have been devised to name organic compounds from the International Union of Bio and Applied Chemistry, and it involves the following components: identification of a chain on the main parent ring that we talked about, and the functional groups or the side chains and functional groups. So the Iupac naming system entails identification of the chains or the parent group, and then the side chains, the functional groups. And in this system, there is also the number of substituents is taken into account. Number of substituents. So still it's trying to emphasize on the procedure for naming of those particular compounds. And then we shall lastly look at what we call the substitutional level and try to see what this concept, we are talking about substituents. So for us to look at the substitutional level, there are atoms and the molecules which are going to be substituted to different degrees. So substitutional levels. This basically, or in simple terms, means, for instance, we have a carbon or this kind of an alkene with hydrogen, or this one. We've talked about isomers, whereby you find that a different group, like a CH3 has been, of course, let's try to expand this, CH, or just CH3, CH2. So you find that a different group has been attached to this particular carbon, or still it can be at this point CH3. So either this one and this one has been attached to the main group. So you'll find that in us naming, we shall have to either use this one since they have the same number, but either of these two, one of them will be considered as a substituent group. So there's a degree to which, this is a single hydrogen, there's a degree to which this substitution can occur, and that is what we are calling substitutional level. Now I'm going to just give a single demonstration of a compound, which is going to assist us to know different levels of substitution of organic compound, and that one I think is going to give us, and last but not least, discussion for the second part of nomenclature of organic compounds. This one attached to this, this one attached to this, this one attached to this, this one attached to that. I've just decided to deliberately alternate those molecules. CH3, H2, H2, and then at this particular point, we shall have a C and a CH3, and then a CH. Okay, I can do away with this now. CH3, and a CH3 attached at that particular point, and then we shall have CH3 at that particular point, and then I shall have a CH3, two CH3 groups attached at that particular point, and then this last one is CH3, and this is CH2. So in this case, we have different points of attachment there and the substitution. The first case is this particular carbon atom, And the second case is this particular carbon atom. We shall look at that. And the third case is this particular carbon atom. And the fourth case is this last carbon atom. Now, what are we trying to look at? As we said that the first member of the alkane series is methane that has got hydrogen atoms attached to it. This is an hydrocarbon, an organic compound. So whenever hydrogen has been replaced by another atom or molecule, we call that one substitution. So if hydrogen has been replaced once from a molecule, then we can call that one the first substitution. 2 hydrogens replace the second substitution. 3 hydrogens replace the third substitution. And 4 hydrogens replace the fourth substitution. We have different names for this particular degree of or level of substitution. Now the first one, we can see that the carbon atom for the second one, it only consists of 2 hydrogen atoms. So which means it is remaining with 2 hydrogen atoms. The second one basically consists of a single hydrogen atom. So this one is 1 hydrogen atom. And then you find that this one has 2 hydrogens. And then you find that the third one, 3 hydrogen. I'm just listing the number of hydrogens which are remaining. So the fifth one, the fourth one, we have a 0 hydrogen atom. So the first degree, the first substitution, we call it, with a 1 hydrogen atom, we call it, whereby there's only replacement of a single hydrogen atom, we call it a primary. 1 hydrogen removed from or substituted by another one, we call it a primary. So of course the substitution came from the carbon atom that is attached there. Now for the second one, whereby there's remaining 2 hydrogens, we call it a secondary. Whereby we have just 1, we call it a tertiary substitution. And then the last one without a hydrogen, whereby all the hydrogens have been substituted, it's known as quaternary. Now we shall have also for different maybe groups of compounds like the amines and the alcohols, the first, second, and third degree for substitution. And that one is going to give us a clue on how, when we find some nomenclature names with appearing of those particular prefixes or numbers, we are able to know what it refers to. So this in a summary gives the first, second, third, and fourth level, which are known as primary, secondary, tertiary, and the quaternary substitutional levels. So lastly, the last concept we're going to learn that is going to assist us in naming organic compounds is about, of course, there's a set of elements in the periodic table that appears around the nitrogen. Of course, these are in the middle that we talked about. Now, these central elements cannot easily lose or gain electrons and prefer to bond or form covalent bonds with the other elements. Especially in the group 1 laws, of course, we shall learn about the periods and the groups, the periodic table. But these particular elements, they form the basis, or they are the most common elements that we are going to see in organic chemistry. We talked about valence electrons. So for that case, we shall have to wind up there, so that next time we proceed to the direct naming of organic compounds. So thank you for being patient. If we are going to learn about this topic of naming of organic compounds, make sure you go through these particular 2 videos that I've done, so that they give you a basis, and some of the names or terminologies which are going to appear can be able to be understood. So thank you, welcome, and God bless you. Bye.